Good afternoon, my name is Shervin and this is Colin. I'll be presenting BioFab3D on behalf of L2D Architects. I'd like to begin by acknowledging the traditional owners, the Wurundjeri people, on the land which we meet today. I'd like to respect their elders past, present and emerging. Today we'd like to start by looking at BioFab3D as very much a new model for medical research, the success of which has led to the new Aikenhead Centre for Medical Discovery, which is starting construction this year, which is why we're entering this project into the awards program in 2023. We'll look at the existing conditions of the site as our starting point before going to the 4 key principles which drove the design. So first and foremost, BioFab3D is a biomedical research facility. It's a prototype that's testing a new model for medical research where engineering is the future of medicine. It's uniting 5 partners: St. Vincent's Hospital, RMIT University, Swinburne Uni, and the Universities of Melbourne and Wollongong. What's very unique about this is that it's co-locating a very diverse range of expertise from different institutions in a clinical hospital setting. We're bringing clinicians, researchers with various backgrounds, engineers and industry to focus their efforts into fast-tracking the translation of research into medical device development. So fast-tracking the D in research and development. One example of this is the BioPen, which we see in the photo on the right, which actually during surgeries can print live human cartilage during procedures. The traditional research pipeline is quite linear and can be quite costly and time-consuming. Issues in our public system get elevated to state and federal levels. Governments give funding to universities and research institutes independently, and over the course of years, research outputs filter their way through to industry, and we then see a response back into our systems, into our health systems with devices. Our starting point was level 1 of the Clinical Sciences building at St. Vincent's Hospital. It's very much in the nature of old lab facilities where we have very cellular lab spaces coming off a central corridor. Our project is a total refurbishment of this space, which was gutted out completely, and the windows to the facade were also updated to meet new regulatory codes. Our 4 key design principles are firstly science in the round, which is about visual and physical connectivity. The shared laboratory and workspace, it's about assigning spaces by function as opposed to assigning them to particular people. Next is built-in operational flexibility, so that as research changes over time, you're not needing new lab facilities. The labs can adjust to suit. And finally, science on display, which is about engagement and ongoing philanthropy. So firstly, science in the round. The floor plate's divided in a tripartite arrangement with a glazed central laboratory in the center in light blue. We have laboratory support zones to the north in dark blue and workspace zones in the south in orange. And these are all connected by a circular racetrack, which is about facilitating the movement of people, consumables and wastes in an efficient manner. It's really very much about connectivity, particularly visual, so that partners coming into this space know who's there, who they can collaborate with, but also passive surveillance of the lab spaces for safety. This is a view from the workspace, looking north through the glazed laboratories. And this is a view from within the laboratories, looking back south on the workplace. The next principle is the shared laboratory. Laboratories are typically assigned to users, but at BioFab3D, they're very much non-territorial. We have 5 partners coming into this space, and they're here because of the functionality that this facility provides. And this is really unique because it avoids the duplication of the same lab spaces in different institutions, and sometimes institutions as large as Melbourne Uni, for example, have multiple labs which are very similar.
And they're coming together to collaborate, so they're working with energy of highly skilled people in an environment where they can use the technology together and speed up the process of devices to market.
So this is one example of a functional lab being for 3D bioprinting of human cells. The workplace also is not assigned to any particular user. There's a variety of settings for different kinds of work. There's large tables for group work, hot desks for individual work, booths for focused work, and lounge settings for conversation, and also a meeting room. Our next principle is built-in operational flexibility. When you're working with microorganisms, the physical containment or PC barriers are very important, and in this facility, we're working with low to moderate risk pathogens, which means that our labs need to be PC1 or PC2 rated. It's really about bringing architecture and engineering, practicing it with operational practices to manage this risk. So what we do is we take our lab zone and we divide it into compartments. In this case, we have 3, and we have a circulation racetrack linking them all together. We have multiple entry and exit points with hand wash and gowning stations. If you ever enter a PC2 facility for moderate risk pathogens, you must wash your hands and put on a lab coat, and when you leave that room, you have to do the reverse. All finishes must be non-porous and cleanable, and it's also very important to control the pressure differentials between spaces. If you open a door into a lab that's dealing with pathogens, you want the air to go from high to low pressure and for the air not to return back out into the space you came from. So here are a few options where the lab can function in different ways. Here, half the facility operates at PC1 and half operates at PC2. We can have most of it operating at PC2 where the door into industry robotics is locked. Or all of it can operate as PC2 where you can't enter into the lab from the workplace at all and you enter from the corridor and lift lobby on the west and east respectively. These 3 options are very important because research is undoubtedly going to keep changing, but what this ensures is that you don't have to keep updating your lab spaces. The lab spaces can, at the flick of a switch, update to suit your new needs. And finally, we have science on display. The extensive glazing showcases the theatre of the science within, and the images produced by scientists in their research work are used as artwork and also as decals throughout the facility. This enlivens the space, but also when they have tours of government officials, it becomes a very strong philanthropic tool as they ask questions about what this represents. And we'd just like to end on a wonderful event that was held at BioFab3D before the labs were certified for use with microorganisms. It was Carol Capek's RUR 2020, written 100 years previously, about the future of robotics in a very much robotics laboratory. Thank you very much.